In the last lecture, I think we have started the integration. We just went through some basic derivation, and we saw what is geometrically the symbolic representation of y dx mean to us. So this was the area under the curve. Which curve? Y x graph with x axis. Okay. So if someone is writing something like that, let's say VGT, then how you are going to interpret this mathematically? Let's forget about the physics. So let's say V is something which depends on time. So V is some graph, some function which depends on time. Then how to interpret the VDT? Which area it represents? Tell me, guys. VDT represents which area? The area under the V antigraph, isn't it? If y dx represents the area under the y and x graph, then VDT will represent the area under which graph?
V and
V and T graph. So it means there will be some sorry, there will be some shape actually, and the x-axis we call the t-axis now. Okay, so we have replaced the name x by the name t, and then for a given interval, we can find the area. Okay, from t1 to t2 or whatever. So if v is really finite, if v is a constant, then the area is easy to find, right? If v is constant, then every point or every point on the graph will have same height, isn't it? What is the meaning of a v constant? The height is constant. Yes or no?
yes.
So let's say if I plot a graph in which a v is represented like this. So it means the graph is a graph. This is a graph in which the velocity is. If I call this as velocity, so what kind of velocity it is representing?
Constant.
Constant velocity. And you can clearly see, because this is the constant velocity, so this area is very easy to determine. How much will be the answer? If I call the height as v, what is the answer then? And if I call this as t?
V2.
Vt. Now this is also the property of a integral, that if the variable, if the function is a constant function, if function happens to be constant function, we can take it out because it will not affect much. So v is going to be everywhere. So whatever will not change, we can take it out. And if you remember, the dt integration is how much? T. Because if nothing is there, we can say 1, and 1 dt will give you t, isn't it? So this will be v into t. I hope you realize this. And we add some constant because this is not the actual graph. Okay. This depends on the interval. So when I write v dt integral, then what is the interpretation? How to interpret this one? So this represents area under which graph? Tell me, guys.
V and T graph.
V and T graph. Now later on we are going to call this velocity and time graph. So in a way, the entire graphical question of kinematics can only be answered if someone really understands the meaning of it. If you don't understand the meaning, probably the graphical questions will not make sense to you. Okay. So we need to understand the graphical meaning of everything. If I write a dt, so this is the area under which graph?
Acceleration and time.
Very good. So this is the area under acceleration under AT graph, A and T, acceleration and time graph. So you will come across variety of things. Let's say f dt. This is the area under which graph?
Force and time.
This is force and area under force and time graph. Area under force and time graph. You can always imagine f as some shape drawn on the xy plane, and then the dt is the interval. I mean time interval, and you integrate for the interval. So if I write f dx, area under force and, so we call it a displacement actually. So displacement graph. Now later on in the chapter, various chapter of physics, everything will get a name or the equivalent value. So this is called displacement. This is called change in velocity. And these all come from definition. This is called change in momentum. This is called work. We have seen this before, right? So f dx graph gives you what? It gives you the work by the force. So every time you see a integral in physics, it should have some graphical meaning. In mathematics, it is just a function for you which you solve. But in physics, we have to develop the intuition to virtually create a graph in our mind, so that we can see the geometrical picture of it. Okay. And because these will have some well-defined notion, so you can further correlate with the notion which is related to them. Okay. So let's see some more thing in physics. So this is also a way of writing ADS or ADX. So this is the graph of which graph? Area under.
Acceleration and displacement.
Very good. Acceleration versus displacement graph. So all will give some meaning. So later on we'll come to know what is the meaning of it. But as of now, knowing the notion is important. So when someone is giving you the graph, you can find the integral. It's the same thing. So let's say if we have a really simple question, let's say a graph which is represented by a straight line passing through origin. Now, can you guys tell me what is the equation of line passing through origin?
Y equal to X.
Y equals to mx, not x, because we don't know the angle, right? So m can be any value, no? So y equals to x is one special case when theta is 45 degrees, correct? Because the tan 45 becomes 1, so slope becomes 1. So what is the general equation? Y equals to mx. And which is the special case of y equals to mx plus c, because the c is the y-intercept. And if you look carefully, the y-intercept is 0. It is cutting at origin. So this is 0 value. So that's why it is y equals to. Now imagine this area is given to you. This is given x. So if this is x, then what is the height? Tell me. What is this value? Anyone? This will be how much? The height is how much?
Y.
Height. Y is how much?
Mx.
So if I ask you, what is this area? Area under the curve. So can you find the area of this triangle?
Mx square by 2.
So half into base into height. Sorry. Is this correct? So answer is mx square by 2, which is the right answer. All of you are okay with this equation, this answer?
Yes, sir.
Now, this is exactly if someone is trying to do y dx, and if I substitute y equals to mx dx, and I can take m is constant, so I can take it out. So what I'm left with is x dx, and I'm integrating from the area is from 0 to x. You can see the interval that you look on the x-axis is starting at 0 and ending at x. And if you compare this answer with the answer you got by the logical interpretation that x dx 0 to x equals to m, you can see m gets cancelled. So this is also a kind of indirect proof that x dx is equals to. Now here we were able to calculate because we knew the area of rectangle, I mean triangle. If it is some other shape, then it's difficult. So integration of x dx is how much? X square by 2, and that's very much easy to be observed or proved. So let's prove a simple thing, something so okay, first I'll draw a graph, then we'll go to the question. What is this area? Area equals to
X.
which is right answer. And from where to where we integrated, from where to where? What is
From
the limit
0
of
to
integration?
x.
0 to x. Very good. Are you all comfortable with the meaning of this? It is 0 to x. Now, how to write the area in terms of the area value? So you write the area, I mean, the integration is y. What is y here? 1 dx. Y dx from 0 to x must equal to x, isn't it? So that is why we write the dx integration from 0 to x is. Now this is like a proof, so that if you integrate from if you integrate only dx, and if nothing is there, so 1 is there. So integration of dx from 0 to x is how much? X. Similarly, integration of dy will be how much? Y. Integration of dt will be how much from 0 to t? Tell me, guys. How much?
T.
T.
Integration of no, any similar, it's a box. Okay, what will be the integration of box d box? Now again, this will go back to the previous question. Integration of input d of input, and if you remember, correlate from the differentiation, it is like the way to read it is input is square. So any input and d of that input from 0 to input is always input is square. Do you realize this? Now x will lose the meaning, so we have to go in a generalized fashion. It is okay, although we have derived using some simple logic, but once the answer is there, we can extend the answer for anything. So this is always equals to how many of you realize this? Does it make some sense to you? So any input and the d of that will always give you the, the input square by 2. So how we got this idea? The x dx was x square by 2. So x is a variable, right? Some input, and d of that. So it is always in this format. So this is a very powerful way to think that if I write sine x, d of sine x, 0 to sine x, what you can expect the answer? Can you guess the answer?
Sine square x by 2.
Are you guys able to understand this part?
Yes, sir.
Okay. So this is having the format, and then later on how to convert this part. So I'll show you something. Let's say let y equals to sine x. So writing sine x is okay, but the other way of writing is, so if you put d both sides, let's say you add d on both sides, so this become d of y is d of sine x. But what is the meaning of this? So go back here. We know differentiation. What is the dy by dx of sine x? What is the first
Cos
derivative? Cos x. So basically, d of y we can write as cos x dx, like a chain rule. Now this is like this gives another idea, and what it gives, that d of sine x is as good as writing dy, but dy we can write as cos x. So d of sine x means you differentiate sine using chain rule and then add dx. So you write d of sine x means d by dx of sine x into dx. Okay. So how to write this one? Okay, if you are not comfortable, I'll just use the chain rule. Can we write this as a d by dx of sine x into dx? Is it same thing? Yes or no? Is it same? By chain rule, we can write this as same, isn't it?
Yes, sir.
And we know d by dx of sine x is how much? Cos x, right? So similarly, if someone is asking you, now this is very important to understand. Okay, as of now, what is d of x square? What is the meaning of it? So you can write as d of x square by dx into dx, isn't it? And
Yes.
then the first term becomes meaningful to us suddenly. And what is the answer?
2x.
2x dx.
So basically, this we can write as 2x dx. Very good. So if someone is saying what is d of u square, the answer is, tell me,
2u du.
what is the d of sec x? Hmm? Tell me. Same rule. What is the differentiation of sec x, if you remember?
Sec x tan x.
Sec x tan x.
So what we should do right here? Isn't it? Can we write like this? Yes or no?
Yes, sir.
Same logic. Now you just see, if you're not getting it, once again. This you can write as d of sec of x upon dx into dx. And this is the answer for this we know. This is sec x dx, 10x. Okay, so what is the d of ln x? Can you guess?
Dx by x.
1 by x dx.
Dx by x, 1 by x dx. Very good. And this is really interesting. What is the d of ex? E power x.
E raised to x.
Dx. Correct? Yes or no? Tell me, guys.
Yes.
Now, if I go the reverse order, I mean, just let me show you something interesting. Integration is the reverse process of differentiation. It is the inverse process. In a way, if I put integral sign both side, and let's say if I choose this function to demonstrate, if I write d of ln x, and if I write something here dx by x, we know d of something. What is the integration of d of something? We just learned what is the d of something integration. What is the integration of d of x? What you got the answer?
X.
X.
So d of anything is
Ln X. Anything.
anything. I mean, see, whatever you write here will come here. No? Are you getting the idea? Yes or no?
Yes, sir.
Which means the d of ln x is actually ln x. That's it. And therefore, this gives the definition that integration of 1 by x dx is actually ln x. And we add plus c to make it, because we are not putting limit. So if you remember, without limit, we are supposed to write the answer and write c. I'll come to that, but as of now, just remember. Now, this suddenly becomes formula that 1 by x dx is ln x. So we are not trying to make a formula. We are trying to understand that why, if a process we know is one process is the reverse of other. So integration is going back to the function. So if differentiation is like a, you take a wheat or some grain and you crush into powder. So integration is like, can we create back the grain from the powder? I mean, that's inverse process. Sometimes we won't be able to, sometimes we can. Okay. So let's say if you take sugar and if you melt, okay, and then convert into powder, you can convert into sugar again by melt, crystallize, and then break into small pieces. So integration is the reverse process. So we can only understand integration if we know the forward process. It means to find the integration is actually to find that function whose forward process will give you the answer. Okay. So that is the whole idea. Like we need to, if someone is asking you what is the integration of 1 by x dx, you need to think that which function upon differentiation will give me this answer. So you will go back to the differentiation chapter and you will see that which function gives you this answer. And then that will become the integral actually. So that is the meaning of integral, the inverse process. Do you realize this? Yes or no?
Yes, sir.
So finding integral is finding the parent whose differentiation gave the function first. So it is like a reverse search. We don't do it. We only try to search. And to search, we have to remember the previous differentiation answer. If you don't remember, the search will be difficult. Understood? So for example, if someone is giving you integration, let's say cos x dx. So how to think about the question? We need to think that, okay, from where we can get cos x? What kind of function upon differentiation can give me this answer? You have to think about. So try to recall what gives you cos x?
Sin X. D of sin X.
Exactly. So this is actually the differentiation of sin x will give you cos x dx, which means the d of something will give you something. So now this becomes like a formula that integration of cos x dx is sin x. I mean, it is not a formula. It's just we are recalling some past incident and we are trying to write it. Understood? Is this clear, guys? Yes or no?
Yes, sir.
So if someone is asking you what is the integration of sin x dx, so you will go back to your history. What gives you sin x? At least sin x with some other coefficient is okay. So what you have differentiated?
Cos x.
So when you differentiate cos x, what do you get? Do you get sin x or something else?
Minus sin X.
Minus sin x.
It means if you have to bring a minus sign, so to match the exact answer, what will do? You'll put a minus here and minus 1 here. Correct? Now you know this will come from where?
Cos X.
So basically this is d of cos x. But minus has come already outside, right? So what is the answer finally? Minus cos x plus c. Do you realize this? Because minus was not there in the present answer. So we have to bring a minus to match the differentiation part, isn't it? Do you realize this, what I'm saying? Cos x differentiation is what? Minus sin x or plus sin x?
Minus sin.
And right now we don't have minus. So what we do? We manipulate. We put a minus inside and minus outside. Now it will match. So this entire term we can write as the differentiation of cos x. We write d of cos x. This is how we write. And d of something is something. So minus was there. So minus of something plus c. Is this clear? Yes or no? Tell me, guys, is this clear? Yes or no?
Yes, sir.
Yes.
Rugved, are you getting it?
Yes.
So if someone is asking you what is the integration of e power x dx, now this is pretty straightforward. What gives you ex? D of what gives you ex? Tell me.
E to the power x.
And so the answer must be same, no? Is this clear?
Yes, sir.
So now integration is pretty easy. Okay. So the moment someone is asking you a question, don't try to get a panic. Think about from where you can get the answer. Let's say I'm giving you a nine new question. X squared dx. Let's say I don't know the formula, I don't know anything. I want to derive it. So first I'll think that okay, from where I can get x squared. What kind of differentiation will give me close to this value? I mean, not exact answer, but at least x squared with something. So what gives you x squared? We all know. What gives us x squared? What you differentiate to get x squared? If you remember?
X cube.
X cube. Very good. But do you really get x squared or something more?
3x square.
Excellent. So you get 3x cube, 3x squared. So when you differentiate x cube, you know the answer is 3x squared, right? But what you are looking for? Only x squared, no? So how you are going to achieve this? So you will write a d of x cube by 3. Now this is meaningful, right? Because
Yes,
1 by
sir.
3, which is coming extra, now will cancel out. So you got the idea that okay, this can be rewritten as d of x cube by 3, isn't it? So what will be the answer, guys? Tell me.
X cube by 3.
See, we are not mugging up the formula. What I'm saying is, this is the right way to approach integration. If you try to remember the formula, which is normally taught by math teacher, which is really bad, you will never command integration. To command, the only way is think that how we can arrive at the answer from which logic, and this you have to develop from right now. It's integration is a vast topic, and then the manipulation is enormous. You will never get to know that how to solve a given integration in JEE. So JEE questions are easy only for those who are good with the manipulation part. Though really no understand okay how to get something from something which we know or something we can convert into. So if I try to create a formula, let's say I want to generalize this. So to get any power, the differentiation term will have at least one extra power, isn't it? We all know only one extra power, because when you differentiate, power will lose the power by the function will lose the power by one value. Correct? So how to get x power n? Can you guess?
X power n plus 1 by.
That's logical. See, that's logical. But you know that when you differentiate x power n plus 1, you will get to n plus 1 also extra as a factor, isn't it? So okay, do it first. Differentiate x power n plus 1. What is the answer? What is the differentiation of this? Tell me.
N plus 1 x raised to n.
Correct. But what we are looking for? Only this value. So what we do? We bring this in the other side. So logically, we should have written something like this to get what we are looking for, isn't it? And we are not trying to derive it. I mean, it's logic. I mean, common sense, I would say. So can we write this as d of x n plus 1 by n plus 1? Tell me guys, yes or no?
Yes.
So what should be the answer? D of something becomes,
X to the power n plus 1 by n.
and now you know this is the formula written in most of the books, right? And when this formula is not valid, when we should not apply this formula, when n is, because if n is minus 1, what will happen? The denominator becomes undefined, right? Something by 0 is undefined. So of course this is true except when n is not 1. Why? Because this is a very special case. Which case is that? N is minus 1. Come on guys, we have done this. This is the case. 1 by x dx. And what is the answer, if you remember? So this is the same question. We could have written like this. And here we don't apply the formula which we just derived. So what do we write here? We need to remember what kind of differentiation gives you 1 by x. And the answer was ln x. Is this clear, guys? Tell me yes or no.
Yes,
Yes.
sir.
Some integrations are not very simple to understand. For example, and that you need in a later chapter. So let's say if I write, let's call z equals to xy. So what is dz meaning? D of xy. So how to write d of xy? So you can say, okay, I can write as chain rule. I will write d of xy by dx into dx. But it is x and y product, so we have to use the product rule to get the answer. So what do you get here? D of xy by dx. How to write this? Tell me guys. How to write this term using the product rule? Tell me guys. What should I write here? I can take one of them outside and differentiate the other, isn't it?
Yes, sir.
So how to write? Tell me.
D of
X
x
into
plus
dy.
y plus
Well,
d of y plus n.
once again, repeat.
D of y plus x plus d of x plus y.
Plus, it's something like product and plus. No? How we write the?
Yes, sir. I'll tell.
Yeah, tell.
X into dy by dx
Very good.
plus y into dx by dx.
Which is 1.
1.
Right?
And yeah.
Whole dx. So dz comes out of how much? It is sorry. It is x dy by dx plus y only. Correct. Let's multiply dx inside, and it looks really nice. X dy plus y dx. That's really interesting. This is like a product rule without much effort. So d of xy is how much? X dy. You can always apply the product rule in a differential form. So one outside other plus y dx. Now, what is the benefit of this is? This kind of integration you will face in entire physics twice. One in the chapter of work energy power, other in the chapter of electrostatics, which is very typical and common problem. And when I ask everyone that how to integrate this one, I don't ask this question. I always ask. I mean, you will get a question something like this. What is the integration of this? So this we can rewrite like this, isn't it? Let me write down the reverse. Look at this carefully. If someone is asking you x dy, integrate this. But this is very difficult to understand. But if you realize this is a product rule written in simple form, like expanded form. So what is the simple form of writing this? d of xy. And now we know d of something is, what is the integration?
xy.
So this is a very, 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 very important equation for you, which you need to know. Okay. So just we can do a small manipulation that we can mentally do it. So if I ask you what is the d of x square y, how it will look like? I mean, not like, what will be the expansion of this? Using the product rule, can we expand this? Tell me guys, can we do this?
Yes, sir. It'll be x squared dy by dx.
The expanded form, how to write this? Using the, this is, I'm asking this part. I have given you this part, how to expand this? D of x square y. So the first term will be outside, x square dy plus y d of x square. Understood?
Yes, sir.
And what is the d of x square, if you remember? I don't want the x or d, I want either dx or dy. So what is the d of x square? Think about it.
X square.
Huh? How, what is the differentiation of x square?
Oh, 2x.
2x.
So how to write this? 2x dx, no? Because dx is missing in the denominator, isn't it?
Yes, sir.
So this entire term, which is x square y, is actually equals to x square dy plus 2x y dx. Now the day you will get such integration, you will get confused how to do this. But if you know that this is some sort of manipulation of something like this, which comes through experience, not in one fine day, but it's good to know. And therefore this integration will become, this is called implicit integration, when x and y both are involved with, I mean, both are a function of each other. So this we can, because we can write like this, so therefore we are lucky, we can write this as, what we can write? Understood? It's very challenging part. I mean, this is really challenging. The most basic one is this one, which is very famous, and I'll urge everyone to remember this. This is actually important to you from the point of view of physics. So you will get the taste of all this at the end of the class 12 math syllabus called differential equation. So when you will study the differential equation, which we use in physics throughout. So the physics is all about differential equation, but you will learn in maths at the end of this. So this idea will help you, okay, so that we can do such manipulation. So calculus is all about manipulation. Integration is especially at a higher degree of manipulation. Okay. So every formula of integral can be derived without mugging up. In case even if you forget, we have a basic steps. Follow it, you will get the answer. So if I ask you, okay, we have done this integration of, let's do this formally. So sin x we have done. What was the integration of sin x?
Minus cos x.
Very good. And but the integration of cos x?
Sin x plus c.
Very good. And let's go back to differentiation. You must have heard this. So which term upon differentiation gives sec square?
Tan x.
Tan x. The answer is tan x plus c, isn't it? Because this comes from, if you differentiate tan, you will get this answer. And so you can rewrite like this. So okay. So then we have formally, let me write down once again. This was how much, guys? Tell me.
Sec x.
And this was how much?
Minus cosec x.
Very good. Excellent. Okay. Anyone who remember this? Now this becomes slightly difficult. Sine cos 10, and this. Okay. And once again, I'll add formally here. So 1 by x dx is how much?
ln x plus 1.
And e per x dx is how much? So now these are the basic things, okay, that we were aware of. Now the moment we deviate from the basic, let's say we know only set of formula, and then suddenly you give me throw me a question which is not direct application of this formula. So there comes the second order of manipulation. You have to manipulate in a way to reconvert into something which you know. Okay. So we'll see some of them. And we can also see the properties of integration, which is the similar to differentiation. So let's write some. And anything which is not in this context, I mean, okay, one formula I will also mention. This is, so x power n dx is how much? If you remember, what is the formula, guys?
X to the power n plus 1 by n plus 1.
Very good. Any other formula you would like to say? The typical formula which we had. Are we missing something from the typical one? Tell me, guys, are we missing something? I think no, we have done the basic one. These are the basic forms, right? Now, anything beyond this we can derive. Anything. So what I suggest, or what I expect, that you guys will remember these formulas. The rest, don't worry, we have method to get. Okay. So I'll give you the indigenous way of thinking. Even if you remember nothing, it is totally okay. So, okay, some properties of integral integral. The first is the multiplication. So if we have any function fx, and if you integrate, and let's say the answer turns out to be some new function capital Fx. So if I multiply a number before the function, because a is a constant which is a multiplier, I can take it outside. So this is a, which is afx plus. Understood? Okay. Understood.
Yes, sir.
Okay, so a fx dx is a of fx dx, and which is, we can just write like this, so it's not a big deal. The other rule is addition and subtraction rule. Addition and subtraction. So if you have multiple functions, let's say a1 f1x dx, or I can just write like, if we have multiple a2 and then dx. So you can split the plus minus and put the integral for every function separately. So it will become a1 f1x dx plus minus whatever it is a2. You can take it outside f2x dx and so on. So very simple rule, not to be mucked up. It's a logical thing. So let's differentiate, I mean, integrate something easy. So we have seen the x cube dx integration is how much as per the formula?
X raised to 4 by 4.
That's very simple, isn't it? So what is root x dx?
2 by 3 x raised to 3 by 2.
So first of all, you have to add the power. What is power? X
3 by
power
2.
3 by 2, and it will come 2 by 3 here, right?
Yes, sir.
So the power and inverse of that. So always remember it is power and inverse is multiplied. So that's easy to remember. So if I ask you dx upon root x, now you have to be careful here. Dx upon root x is how much? X power how much?
X to the power
X
2.
power half.
Half, because minus half plus 1 is plus half, right? Because it is half, so you have to multiply with inverse of this, which is 2.
2 root x.
It's 2 root x. Very famous. It's 2 root x. If someone is asking what is x root x, just time pass. Tell me the answer.
2 by 5 x raised to 5 by 2.
X power how much?
6
5 by
power minus half.
So it is minus 3 by 2 plus 1, no?
Yes, sir. Minus half.
Power is minus, no? You are adding minus plus 1. So how it is 5? How much is the answer? It is minus half, correct?
yes.
2 by root x.
And because it is minus half, so minus will come outside. No? It's minus half, so answer will be minus 2. Inverse of it, isn't it?
Yes, sir.
Okay. I hope this is clear. Okay. So this is minus 2 minus half. So if you want, you can write as minus 2 by root x plus. And of course, some degree of manipulation is always there. So now if I ask you what is the x plus x square by 2 root x dx, again, you know what to do. So we can actually break it down into pieces, right? And we can integrate each piece and then add them together. So can I do this for me? Everyone, please. What's the answer?
5x raised to 3 by 2 plus 6x raised to 5 by 2 by 15.
The first one is 1 by 2 will come out, and then I can get something root x dx, which is 3 by 2 by 2 by 3. The first term will give this much. Second term is 3 by 2. So 3 by 2 will become 5 by 2, and it's become 2 by 5. And this is the answer, right? It is the answer.
Yes.
Come on, guys. Is it done? Yes or no?
Yes, sir. Same answer.
Okay. So you can just rewrite each term. X by 2 root x is like root x by 2. Then you can integrate. The second term is having same thing. Okay. So okay. Next. Sin x okay, now we'll see some question in which the formulas cannot be applied directly. We have to do some manipulation. And one particular formula that we generally come across is let's see if someone is writing you sin x cos x dx. Now tell me, you can see there are two terms which are multiplied here. So there are many ways of solving this, but we will come to the other part later on. And if you look carefully, one of them is differentiation of other, isn't it? Do you realize this? One is the differentiation of other. How many of you are able to realize this? That
Yes,
cos
sir.
x is differentiation of sin and vice versa. Okay. So if you look carefully, again, without knowing the formula, the other part is cos x dx. And we have seen that this can always be written as d of sin x, isn't it? And now you can see there is a complete match, input, D of input. And the moment we have a complete match, you can replace the match by any symbol. So you can call let t equals to sin x. And the moment you do it, you can see a formula like t dt. And you will never feel that, okay, it's a trigonometric function. It's like a algebraic function. And what is the answer for that? Tell me guys, what is
T
the answer?
square by 2.
T square 2 is the right answer, which means now what was the actual value? Was it t or something else?
Sin x.
So the answer is actually sin e square x by. Isn't it easy? At first go, it didn't look okay, like we can solve. But now it is very easy because we know that the ultimate format is easy. So the rule is when we have a function and if you are able to see its differentiation, it is always easy to solve question like that. So I'll give you some strong question. And again, I don't want to put into the category of formula. I mean, we want you to learn this organically. Because formula you may forget, but this organic development of idea will never go out of your brain. So I don't know how this question will respond to your brain, but let me write down. And do you see something? Do you see something? Do you see the differentiation of one another? And if yes, then what you see? What can be differentiated to get the other?
So x square can be differentiated.
Yeah. So I would say when we have x square plus some constant, why don't you take the entire constant and x square together? Because when you differentiate, one will anyway go away. Correct? So the logic is I want to make it simple. It should look simple, not this much complex. And I can realize that the x square plus 1 can be converted into something simpler. Okay. And because why I'm saying this, because the differentiation of that part is available outside. So we can make use of that differentiation part. So what we do is we call it the method of substitution. I mean, of course, you can always put a name and name game. So we call it method of, but I think it's a logical decision that one should go through. And you know that this doesn't look nice. So if you take this entire term as something, then the differentiated term is because available outside. So we can do some magic. What kind of magic? Let's see. So method of substitution. Okay, what we do here? Tell me what we should substitute. What you want to get rid of? X square plus 1. So you can choose any symbol. I always take T. If you want, you can take Z or U, whatever. So T I am taking as x square plus 1. What is the next step? I will differentiate. Why? Because I can see the differentiated, the part which will come upon differentiation is available in the picture. So dt will be how much, guys? Tell me. D of x square, which is 2x, dx, and 1 will be 0, correct? Or if you're not comfortable of this way of writing, you can write formally dt by dx both sides. So you get 2x, and then you will rearrange as dt equals to 2x dx. Now you can pick in one of the way of writing. If you're comfortable directly writing, it's really good. You can save your time. But if you find, okay, no, initially it's difficult for me, sir, then the idea is differentiate both sides with respect to x. Okay. I hope this is clear.
Yes, sir.
Yes, sir.
And now you can see the dt is the term which is x dx, and x dx is in a way available here, right? We have this term, but we have 2 extra. So that's not a big deal. The 2 extra we can get rid of easily. So I can take dt by 2 one side, then now we have perfectly x dx. Okay. Yes or no? So this we can write as x square plus 1 power 2 2 2 2 2022, and then I have x dx, and we clearly know that x dx will convert into dt by 2. So this will eventually become t to the power 2 to 2022, and this will become dt by, isn't it? If you're not comfortable even with this idea, the simple rule is, this is called change of integrator. So what we do is we change the integrator. We are trying to convert the previous integrator with the new integrator dt, and to do so, we can clearly see that dt is actually 2x dx. So dx is how much? If I, let's say if I write from dx is how much? dt by 2x. So let's substitute the integrating with a new assumption x, and dx we can write as dt by 2x. And if you remember what we assumed this to be t, so x will get cancelled out. So this is t power 2022. It is all up to you. Whatever you find comfortable, whatever is easy to your brain, go ahead. You will get the right answer. So, but it's good to know that this entire expression, which was appearing difficult at first go, now it is so simple. And 1 by 2 is constant, so we can take it out. And we all know the integration of this. What is the answer? Tell me, guys. The integration
T
is
raised
how
to
much?
2023 upon 2023.
Correct. Let's see. And now we can substitute back the t which we started with. So 4046, and what was t actually? So now you know the answer for this kind of integration. Is this clear, guys? Tell me.
Yes,
Are you
sir.
able to understand this part? So do you see the logical way of approach? I mean, not saying see, I mean, maybe I can tell you some name to this. I'll give you some method and so on, but I really do not want you to remember the method. Just remember the process. So the process will always help. So for example, if I write here, and that's very logical, sine cube x cos x dx. What comes to your mind? What I should substitute the t value to make it integrable? Tell me, guys, what is your takeaway? You see the differentiation again, similar way. So sine cube x is not a differentiation of anything which we know, but cos x we know is the differentiation of what?
Sin x.
So what must we substitute here for t value?
T should be sin cube x.
No. If see, if you take t as sin cube x, the differentiation will not give you cos x, isn't it? You must take something which can give you differentiation.
Sin x.
Only sin x, no? Are you getting it? Everyone, please.
Yes,
Tell
sir.
me. So now you got the idea that I must take t as sin x. Then what the equation will look like? Once you substitute, what will you get? So everyone start writing the way I'm saying. Write such let t equals to sin x. All done? Write with me. T equals to sin x. Done?
Yes, sir.
Yes.
Differentiate both sides with respect to x. What will you get? Or simply, if you want to connect dt equals to dt, we connect as
Cos
if
x dx.
cos x dx, and you can see it's there in the function integral. So this integral can be rewritten as what?
dt.
Only dt, the entire integral.
T cube dt.
Excellent. So the moment you substitute t equals to sin x, this entire integral will convert into d cube dt. Tell me, guys, yes or no? And you know the
Yes.
integration. You know the integration. What is the answer?
E to the power 4.
So 1 by 4 and t power 4 means sine power 4x. Is this clear, guys? Tell me. Yes or no?
Yes, sir.
But sometimes it will not be obvious. So let's say the next question. It is simply sine cube x dx. How to approach it? What we can do? Any manipulation of from trigonometry is okay.
So can we use sin 3x?
Of course, you can use, no problem with that. But there is a simpler way also. So we'll come to that also. But there is always a simpler way of solving question like this. You can see the power is odd power, so I can always take one of the number, like one of the value outside, then we have square power. So this we can write as sine square x into sine x. But we know that the differentiation of sine cannot be sine. But luckily we are good to in a position to convert this into cos formula, isn't it? So sine square x we can write as, any guess in terms of cos?
1 minus cos.
Very good. And now you can see something that what will differentiated to give you something in the function. In this integral, what you must assume to get its integral, sorry, it's a differential. So what we must substitute t here? Can you guess?
Minus cos x.
Minus cos x. It's very good. So it's good to substitute only cos x. That's also fine. Because we can substitute minus, that's at the end of the result. So you got the right idea. Can you proceed and tell me the answer, everyone? Please go ahead and tell me the answer. Yes, guys, got the answer?
Sir, I'm getting the answer as 1 by 3 cos cube x minus cos x plus c.
Yes, sir. Same
Okay.
answer.
Yeah. So I think the answer is correct only. Just let me confirm it. Writing it. So what you did, you substituted t equals to cos x, right?
Yes, sir.
And the dt becomes minus sin x dx, correct? So basically sin x dx we can write as minus dt. So we will substitute as 1 minus t square minus dt. That's it. So the final answer is what you got is correct. I think this was the answer, right? So sin cube x dx is understood.
Yes, sir.
This was the answer. Okay. The other method is also correct. What Prasansa mentioned, that you can directly use the formula, but there is a problem which we'll try to address now. So what is the integration of sin x? The answer was
Minus cos.
minus cos x plus c. What if I write sin of ax? Now the x is multiplied with some number, a is a constant. Then how we can write the answer? So we need to match the argument. This argument we have to match here. Then only we can use the formula. So the argument will be match how? It's very easy to match. We can write it as ax and we can divide by a, isn't it? Because a is any even number. Am I right?
Yes, sir.
And once it will match, you can take 1 by a outside, then it is like sine of something into d of the same thing. And the answer we know, sine of x dx is minus cos x. Okay. So the answer becomes how much? Minus cos ax, but a will come in the what? D numerator. So when you multiply with some number to x, you have to rewrite this in the same fashion, and therefore you have to divide by a, and you're done. Is it difficult to remember? Or it's okay? It's okay, yes or no?
Yes,
No,
sir.
Harlan. So the simple rule, this is like a rule of thumb that the rule says that if integration of fx dx is f of x plus c, any change in the, if we scale the value x, if we scale the input parameter x, then answer will be as per the input parameter, but we have to divide by the coefficient. This is you can say a generalized way of writing, and this will eliminate the purpose of remembering the answer or deriving it. So you can just write the answer, but once you write the answer, divide by a. Understood? So for example, if I ask you, can you integrate sine 2x? So here we have sine 2x, but here we have 2x, but here we have x. So you can treat as x as of now and write the answer. What is the answer? Minus cos 2x. But whatever is the coefficient of x, which is 2 here, what you're supposed to do? Divide by that number. Come on, guys, tell me, are you able to get it?
Yes, sir.
Or if you don't want to do this, if you want to do it from scratch, you write d of 2x, but d of 2x is what? 2 dx, right? So I will to divide by 2. And now anyway, I'm going to get the same answer now. So it's the same thing. So the benefit is like if I have something like sine of kx dx, which is very typical in physics. So what will the answer tell me, guys?
Minus cos kx by k.
Very good. If I write cos omega t dt, what will be the answer?
Sine omega t by t da omega.
Very good. So is it difficult? The second idea is if I write something here, adding any number to the function will not affect the answer. Why? Because differentiation of any constant is 0 only. So what will be the answer here? Can you guess? Tell me, guys.
Minus cos 2x plus 3.
That's it.
Upon some
Upon the coefficient of x.
2x plus
2.
eh? Only 2,
2.
no?
2.
Oh, sorry.
See, listen, now you got confused. That's really good. What will happen if you differentiate this? You'll get a number,
You
right?
get 2.
2.
You get 2. So if I see, I know that for any linear equation, the differentiation itself is number. So we can get 2, right? So the best way is, if you get confused, you just take that out and make it a single value. And then what you write? Differentiating both side with x. So dt will be how much? We can directly write answer. How much is dt, guys?
2 dx.
That's it. And now you substitute back. So sine t and dx we can replace by dt by 2, which is as good as writing sine 1/2 sine t dt, and we know the answer. Minus cos t by 2. And what is the t value? Whatever you assumed. Now, see, for trivial question like this, I mean, there is no need to apply the method of substitution. Of course, that is the way to approach, but the idea is it's good to remember the fundamental relationship to save time. Okay. So in the very beginning, you can, of course, do like this, but the rule is simple. Any, if you replace, so again, I can make it as a formula and will force you to mug up, but that's not the way one should understand integration. So integration of f of ax plus b, it's like I'm converting the x by, it's a linear combination, which we have done in the differential also. So this we can always write the answer as f of this. So whenever you see a linear combination of x instead of x, the entire formula will not change, only some extra factor will come. So either you use the method of substitution to make it simple for you. I mean, if you don't remember, all you simply remember the formula, that's equivalent. I mean, these are very trivial problem, and putting so much effort for a trivial problem like this is kind of wastage of your effort. So if I ask you what is the integral of dx by x, what is the answer?
ln x plus c.
So if I write dx by 2x, this is simple question. 1 by 2 we can as a take as factors. This is 1 by 2 outside, and again the answer is 1 by 2. But if I ask you, so it is still dx by x because everything else is constant. So what the answer? What you can guess? Tell me guys, what is the answer?
1 by ln ax plus b.
1 by
A
ln
ax plus b.
Very good. Or again, the moment you see feel like okay, I'm not comfortable with what I remember, you go with substitution. So you will make the ax plus b as one single term t, right? How you would have solved from basic. So let t equals to ax plus b. So the dt is definitely a dx because b is going to be 0. And now we are done. The dx current as a dt by a and t. And this is again a very simple form. It takes no time to solve. It actually takes no time. But even that time is important to us. All right, guys. Does it make sense to you?
Yes, sir.
Everyone tell me.
Yes, sir.
Yes, sir.
So if I ask you this question, very good. So question is, what do you think the answer should be? Or do you see some pattern in? Okay. So when you don't see anything, the best way is, can you look for something which can differentiate it to get something? Look at the power of numerator and the power of denominator. It is differing by 1 only, right?
Yes.
And we know that when you differentiate a bigger power, you get a small power. So what we must substitute here? Can you guess? What we must substitute here?
1 plus x square
As t.
as t.
So proceed, go ahead. You got the idea?
Done, sir.
So what is the answer?
1 by 2 log of 1 plus x square plus c.
Very good. Anybody else getting the same answer?
Yes.
Very good. Now, the plus C has been a mystery for long, but it's not very mystery. So let me just give you a small idea why plus we write plus C. What is the differentiation of x square? We all know the answer 2x. What is the differentiation of x square plus 2? Same answer. What is the differentiation of x square plus 3? So it means differentiation of any number, if some constant is added, will not affect the answer, which means if we know the differentiation is this much, we have no idea about C. Like what is C, it must be there to give you this answer. Any C can give you this answer. So when we do the integration, we write the answer x square, and because we know any number, if you taken in the beginning to get this answer, so the reverse process is we add C, because we don't know, because the differentiation of any constant is 0. So we do not know the exact function. Okay. So let's take some example from physics. Let's say charge flowing through the cross section of a wire is written as a function of time t as 3t square plus 5t plus 2. And the current is defined as rate of flow of charge, which is the differentiation. So if you differentiate, what you get? Tell me. Tell me the differentiation first.
60 plus 5.
Now let's try to integrate 60 plus 5. It's a reverse process of getting the charge back. And you integrate with 3. I'm not giving the limit. So if you integrate, what will you get? Tell me the answer. Tell me, guys.
3t square plus 5t plus c.
You can understand that we are missing the last term, right? So when you integrate back, you miss the term which it was there actually. You got C. And you have no idea what is C. So adding C is important because we don't know what is C. I mean, what was the missing factor? It could be 0. It could be 0, but we should know that missing factor. So when you solve question of physics, the missing factor we derived from the initial condition of problem. So in the problem, they will give you some initial condition or some condition they will give you. For example, if they say at t equals to 0, the value of q was 2. At t is 0, q was 2. And we got the q formula. So what is the q formula? 3t square. So q at 0 will be how much? 3t, okay, this is 0 plus c. So q at t equals to 0 turns out to be c, and it is given it is 2. So now we know, oh, c is 2. And then we substitute back the unknown which we assumed, and now we get the exact function. So in physics, there is a whole lot of idea called initial condition. And the purpose of initial condition is to eliminate the c value. Okay. So when you integrate, of course, you have to write c. And c can only be eliminated if someone is giving you the initial condition. In maths, because we are not solving any real life problem, we just solve numerical, we just integrate. So there we only write c and we are happy with it. In physics, we have to substitute c with some meaningful answer, which we do using the initial condition. So this is called method of initial condition. I mean, of course, you find the unknown using the initial condition or some condition. So I hope the idea of c is clear. Why we write c? It should not bother you much. Are you all guys able to get this answer? Everyone?
Yes.
Yes, sir.
Oh, very good. So can you guess the answer? So what will be the answer here? So what do you see here? If you, when you don't see any formula, because it's cortex dx, basically this is a cortex integration. And for cortex, we don't know any basic formula, because in the basic list of formula, cortex was not there, right? The moment this happens, we go for, we look for or hunt for differential of one, like what we can differentiate to get the other. So we always look for the denominator. That if I differentiate the denominator, what I'll get? I'll get the numerator.
So is the answer ln sin x plus c?
Yeah, correct. So the answer is ln. Because log cannot be negative, so we put a mod sign before the sign. Plus. So we first to get the answer, then once you get the answer, you can write like this. Okay. So if I ask you what is the integration of tan x dx? Then minus will come into picture, right? So what will be the answer? Tell me, guys.
Sir, minus log of cos x plus c.
So we put minus inside, it will come sec x. And then we put a mod sign because at the end of the day. So first you get the answer, and then you can put a mod like this. Is this clear? Now, one very interesting formula which is, so we have derived the integration of sine, cos, tan, cot. What is left? Second cosec, right? So now these are very tricky ones. What is the integration of sec x dx? And perhaps there is no way to get, but there may be someday. So you can do it in multiple ways. So this you can add as 1 by cos x dx, but still nothing comes to my mind. So can we write like 1 as sine square x plus cos x square x? Then we can break it individually because the whole will not make sense. Okay, up to this much effort, I can get the right one. We can do this integration easily, but still there is a problem here. Okay, there is a problem. So we can further go. Okay, can we write like 1 minus cos square x dx by cos x plus cos x dx. What we get here if I do so? Oh, it will cancel out if I write it once again. 1 by cos x dx, which is sec x, minus cos x dx plus cos x. Okay, I proved that. Okay, both are equal. Oh, so you can see that this will not work. The reason is this problem is a very unique problem, and anyone solving for the first time, this will never click. So you need to know some trick, and the trick is, this is very special one. So this is a something that no one can do it with common sense. It is like something which you need to know, and because you're learning for the first time, so it's good to know. So let we take a value t equals to sec x plus tan x. Can you differentiate this? What is dt by dx? Tell me, guys. The first term will give you how much? The differentiation of sec. Just tell me, Prasan sir. What is the answer for
So
the
sec x
derivatives?
tan x plus sec square.
Very good. You know what is interesting here? You can take one thing common, and you get something like this, which is like exactly what you started with, right? So if you differentiate a number of a function like this, it will give you sec x into the function. That is why this is actually written or rewritten as and now you can see that the numerator is the differential of denominator. Do you realize this? Are you guys able to realize this? The numerator is exact differentiation of denominator. Yes or no? See, if I multiply and divide by the same function, it will not affect the answer, right? But fortunately, this becomes in a format which we know that the numerator is the differential of denominator. Is this clear? Yes or no? Tell me. Do you realize this?
Yes, sir.
Yes, sir.
So the entire numerator we can replace by dt if I take the denominator as t, isn't it? So this will become dt by t. And what is the answer for dt by t? What is the integration of dt by t? 1 by t?
ln.
ln t. We are done. So now this is a very famous answer, and we should remember this is ln mod, we put sec of x plus tan of x. So you will come across this in physics quite a few times, in maths a lot. So sec x dx is ln sec x plus tan x, and there is a very similar relationship for the cosec also, but that I want you to derive. It's the same process. Can you think about what we should write to get the cosec dx, cosec x dx integration? Because that is the last trigonometric formula that we need to know. The rest we have done. So what we must multiply and divide to make it a pattern? Think about it. It's a almost simpler. Come on, tell me.
So cosec x minus cot x, and we take it as t.
Yeah, so t should be taken as cosec x plus cot x, right? And if you differentiate, you will get a minus cosec x into the same term, right? Is this clear? No, I mean the order is different. You can write as. So the cosec will give you minus cosec into cot x, and the cot will give you. You can write it directly, and cot will give you minus cosec square x dx. So we can take minus cosec x common. So actually we can rewrite as okay. So this turns out to be how much? Now you can see that this is minus dt by t. So what is the t value here? You can see clearly. So for cosec x dx we can write as minus ln. You can keep minus here. Cot x plus. Okay. So all the trigonometric formula we have done. Let's do something from the exponential formula. We are done with the logarithm. We are done with the power formula. So quickly we can go to this is not exponential, it is a power x. So how to get the answer if you remember? A power x we can write as how to change the base from a to something else. So how to change the base as e, because we know e power something. So the goal is, can we convert this into base e? Let's say if I choose t equals to a power x. So if I take ln both side, ln so ln t will be x ln a. Now because ln means exponential, so t we can write as again e power. I hope you remember this. We have discussed this in the differentiation. So any base which is not exponential, we can take e power x and multiply the ln of the base, the new base. So a power x can write as e power x ln. Do you realize this? Yes or no? Difficult, right? Try to do it on your own. Feel it. First derive this. So first we write t equals to a power x because the variable is in the power. We take the log to bring it to the base. You know, so when you take a log of a power something, something becomes multiplier. And now we take the inverse process. So we know if ln t is something, ln is e base, right? So the t becomes e power x ln. So this we can write as e power ln a into x. And what is the answer for e power kx if you remember? Because ln a is constant. So we have done this now. What was the answer, guys? Tell me. What is the integration of e power kx? Am I audible?
Yes, sir.
Tell me the answer.
Sorry, power K. The same.
E power.
Kx.
That's it. Here we have kx and here we have x. How to make it kx? By dividing by k and multiplying with k, right? Again, you guys have gotten the things so quickly. So we simply we did just a minute, some minutes ago. So the answer will be 1 by k. K is how much? But this you can again reconvert into formula. Is this clear? Tell me guys, is this clear? Yes or no?
Yes, sir.
So
Yes, sir.
what I said is derive on your own once again without looking at the answer. Solve this. See if you can get the answer through the basic. And if yes, you can solve another problem. Let's say
Yes, I got it.
Yeah. So you got the first answer, a per x dx on your own.
Yes, sir.
So the answer must be this way. It's only ln a. Okay, what about this question? Do we need to change something? No. We can just write as ln. No, ln what?
So 2 ln.
2 ln. Correct. And if you want to do it from the basic, you are always free to do it from basic. So you will take t equals to. Then you can take ln t. And you can multiply the terms. Ln t equals to 2 ln a into x plus 3 ln a, which is just a constant. Okay. And what is next? Then you take t, I mean ln, but not t, you can get t equals e power 2 ln a x, and any constant of power we can write as a multiplier. This is the entire term is constant, and then we know how to integrate, and if you rearrange, you'll get the same answer. So this is the answer. The best way to remember is any linear combination will not affect the answer. Same answer. Only difference is the coefficient we have to divide by 2. Correct? Is this clear, guys? Tell me.
Yes, sir.
So what is the integration of 2 per x dx? See, simple question. So answer is, tell me guys, what is the answer?
2 power x by ln 2 plus 6.
That's it. So what is the integration of 3 per x dx?
3 power x by ln 3 plus 6.
No, something more different. So this is again one part of the question that you did. I'll give you homework, a lot of question to practice. So let me take you to the next variety of question, or next type of integral, where again we need to rethink. So imagine if I give you something like this. Dx upon 1 minus x square. First of all, you cannot see anything like differential of 1 is given. So we have x square and we don't have x term anywhere, right? So it means we cannot differentiate and get something. Okay, so that's one problem. What is the second problem? It is not fitting any fundamental formula which we have done so far. So how to proceed question like this? Can you guess how to proceed? Any idea? Tell me, guys. Tell me, guys, do you get any idea? Yes or no? But I can suggest you something. This is entirely question based on trigonometric relation or identities. So before we begin solving a question like this, let's put down all the formula once again for the sake of understanding. So sin square theta plus cos square theta is how much? Tell me.
1.
1.
Sec square theta minus tan square theta.
1.
and cosec square theta minus cot square theta.
1.
So that's very famous. So can you correlate 1 minus x square? We can 1 minus x square we can write as either, if I take this side, it is like 1 minus cos square, or if I take this side, it is 1 minus sin square, right? So it is matching a format. So I think this having the inspiration from this formula, 1 minus, because we can write a 1 minus square of something else, the square of sine. So 1 minus cos square is sin square, and 1 minus sin square is cos square. So this is really interesting. And because of this interesting feature, I'll show you something else. If you look at this equation, 1 plus x square, where it is matching, which formula? I mean, which identity? So which identity will fit in this expression? And then here, what do you think? What will fit here? Any guess? Which equation? See, something square minus 1. So something square minus 1 will come from the last two equations, right? Like sec square theta minus 1 is tan square theta, or
Yes, sir.
cosec square theta minus 1 is cot square theta. So when we have some constant minus x square, it is the first equation. But if it is x square minus constant, it is the second or third equation. Okay, that is the whole idea of all such integral. So what we must substitute logically to get rid of the square root, or to reduce the term, what we will substitute in the first case? Imagine I am taking the first case. What is the logical substitution here about x? What I must write x so that I can get rid of this root term? I want to get rid of square root term. What I'll do? So you are free to substitute x any trigonometric ratio. Which ratio will help you in this regard? Tell me.
So, sir, x you can write as cos theta
Cos theta
or sin theta.
sin. So what we should go with? I mean, both are okay. Both are okay. Now, which one is better choice? Cos theta or sin theta? If you choose cos theta, what is the problem? The differential will give you minus sign. So one extra minus will come. But if you choose sin theta, its differentiation will give you
Cos theta.
which is free from the sign, right? So what is the logical substitution? Logically, we think that the x must be given a value. So here what we write is, let x equals to sin theta, because we can easily find dx. What is dx? Tell me, guys.
Cos theta.
Cos theta d theta, right? Now go back to this formula. We can write as cos theta d theta upon 1 minus. And what is 1 minus sin square, by the way?
Cos square.
And what is the root of cos square?
Cos.
See, such a nice answer. Can we integrate d theta? Integration of d theta will be
Theta.
just theta. So can we find theta from here? What is theta, guys? Tell me. Theta is
Sine inverse x.
exactly. And that is answer. These kind of questions will give you inverse trigonometric function. So basically, this is sine inverse x plus. Do you realize this? Do you realize?
Yes, sir.
Maybe. Maybe. And why it is so interesting? I'll tell you something interesting about this. These are inspired from the circle. So we know that x square plus y square equals to a square represents circle centered around origin, isn't it? So if I draw a circle of radius a, okay, if I draw a circle of radius a, this is a. If I call this as x, what is the y value? Y will be how much? Tell me, what is
X
y?
square minus x square.
A square minus x square. Very. Let's try to understand. If someone is writing dx upon a square minus x square, try to understand. Okay. So I can rewrite as a dx upon one by, because a was not there. And if I look carefully, a upon a square minus x square, what it is representing by the way? Or it's good to write as dx upon. What is this representing?
Sin theta.
It is sine theta. Or yeah. It is representing sin theta. And what we know is that the x we can write as a cos theta, isn't it? Can we write x equals to a cos theta? Yes or no?
Yes, sir.
So dx will be how much? Minus a sin theta d theta. Okay. And now y minus is coming. That's a different debate. Generally, we can get rid of this minus. Okay, let me just make a small change. For some obvious reason, I'll tell you why. What's the reason? So the change I want to bring here is the assumption of theta. I will take theta from vertical. This is theta. Now, with this change, you can see that this will become 1 by a. And now this is dx upon a square minus x square upon a. And what is this now? Now this will become
Cos theta.
cos theta. I mean, that's whole idea. And x we can write as a sin theta, correct?
Yes, sir.
As per this new. So dx becomes a cos theta d theta. I just don't want to get the minus sign, that's why I did it. So you can see clearly that without even knowing the integration, I can solve this in my way. So I can replace dx by this and okay, yeah, fine. So now what I'm getting is simply d theta and the integration will be theta. And I can see the theta here in the formula. What is theta here? So you can choose any value of theta. I can, because I started with this. So theta here is how much? Sin inverse x by a. And so I'm done. So my answer is using the circle, we can derive the integration like this. So every trigonometric function we can derive from the circle. I'll tell you how to draw a circle. That's a very interesting part. So every question we can derive. So the best way is, I mean, of course, this you can uh, practice on your own. Try to think about it. But I'll give you some generalized process to proceed. So the first question is done. The way to process is dx upon. We have done with the basic also, I hope so. Yeah, we have done with basic. So if I write dx upon x square minus a square, just so let's say I think the dx upon x square minus c square. Okay, before we solve, can you think about the proper substitution? What we must substitute x to come out of the root? Tell me. From the formula, trigonometric formula, the identity that we wrote earlier, which one will have the format like this? I can clearly see something square minus constant is this format. Also, we can do it from here also, but I will always prefer the sec one because that gives positive answer. So what we are going to substitute, guys? Tell me. Can you guess?
Sec theta.
Correct. So substitute x equals to not sec theta. We will substitute a sec theta. Why? Because we want a to be common. Then only we can proceed, isn't it? And the moment you write this, what is dx you are getting? A sec theta tan theta d theta, right?
Yes, sir.
So this we can rewrite as a okay, tan theta, and the denominator becomes a outside, and sec square minus 1 is tan square, which is tan theta. All gets cancelled. Really nice. What we are getting? And this we know the answer. We have done this before. So the answer will be ln sec theta plus tan theta plus c. So not a very easy answer, but this is the answer. We have no choice. But we want answer in terms of x, so sec theta I can write as x by a. Tan I can write as and then again I can write as ln x by a plus under root of so many steps, but that's okay. And because a is constant, so we can eventually write as, because ln a by b is ln a minus ln b, and ln b becomes constant. So constant plus some constant is another constant. So this is for indifferent case we can simply write some c as. So this is the difficult, most challenging integration you will come in physics. I mean, of course, this is not the most challenging in maths. In maths, it's a trivial question, slightly good question. But in physics, this is the difficult which will come across. All this requires good practice, and only with good practice you can get the answer. Okay. So with this, I'll stop today's lecture of integration. It is still not done. So next lecture will be some more realistic integration, like integration which we need in physics. So the next lecture is going to be very, very, very important for all of you. So don't miss it. Okay, so I'll send you questions for practice, and we'll see you in the next lecture. Bye and take care.
Sir,
Yes.
sir, I had a doubt which was taught in my coaching class from normal constraints.
Yes, tell me the doubt. Although we don't have space left, I have only this much space to explain. So what you want to ask? Is it laws of motion question?
Yes, sir. Sir, I've sent you the picture.
Okay, just okay, fine. Okay, now normal constant. So don't worry about this. So these are very easy one when you study laws of motion. Basically, the way to think about it, just
So can you send the question on the group also?
yeah. Presence can share directly in the group. Yeah? That's good for everyone.
Yes, sir.
So to understand the idea, I mean, this question of any called normal constant, the simple rule, there is a rule. These are hard objects. Hard means they are rigid, and therefore you cannot deform. You cannot, press it and make it shrink, or so they cannot, they cannot be compressed. So we call it hard, or to more technical way, we call it rigid bodies. So when two rigid bodies will touch each other, and you can think common sense. Let's say there is a cylinder, there is a some inclined plane, which is typical of question. You don't look at the entire diagram, that will be confusing. Look at the point where they touch each other. So this is the point of contact. We call it point of contact. Okay. At the point of contact, we think of 2 points, one belonging to my cylinder, but the other belonging to the plane. They are technically two different points, one belong to each body, but these are called points in contact. Okay. Now I don't know how the cylinder is moving this way or this way or this way or whatever random direction. And even I don't know how this wedge is moving or cylinder, the plane is moving this way. I mean, I have no control over how they are moving. So we don't think about what they are moving. But what I really understand that to maintain the contact between the 2 points, this line is called the common normal direction. What do you call? Common normal. So there is the idea of common normal, the line which is common to both the surface. We call it common normal. Normal means perpendicular, basically. Okay. Now, to maintain the contact, if the cylinder is having velocity, let's say, in some direction which you don't know, let's say like this, which is a typical case, and the plane is trying to move this way. Let's imagine for a situation. And this is angle theta, and technically we have a wall supporting the cylinder, so cylinder cannot move left or right. It can only move downward. Okay. So imagine situation like this. Yeah, that's fine.
Sir, are you sharing the screen right now?
It's not shared.
Sir, I am not able to see the
There
screen.
it is.
It is. Are you able to see the screen? Yes or no?
Yes, sir, I can see.
Sir, I can't see it.
Oh my God, this is a strange phenomenon. Just a moment. Let me stop for sharing. Let me restart the sharing. Can you see now?
Yes, sir.
Oh. Oh. I'll do it a bit. So the idea is simple. You draw two lines, or vertical, any horizontal line. Draw a wedge. Draw this cylinder. Now, if the ground is fixed, as we know, ground is always fixed. What is the possible direction in which wedge can move? If wedge has to move, then how the wedge will move? Tell me. So wedge can only move along x,
Yes, sir.
isn't it? There is no option actually. So we'll draw the arrow of the point of contact for the wedge. So this point is in touch and this point is trying to move this way. How the cylinder will move? So you will come to know cylinder can only move downward. So the point which belongs to cylinder will move downward. And we draw both the arrows only at the point of contact. We don't draw anywhere else. And the next step is draw the common normal, which is the line which is perpendicular to both the surface. And the next step is find the angle. If the wedge is trying to move with velocity Vx and the cylinder is trying to move with velocity Vy, the simple rule is to maintain the contact, the component of velocity of wedge as well as cylinder along the common normal must be equal. Once again, to maintain the velocity, the component of velocity of wedge as well as cylinder in the direction of common normal must be equal. The other way of saying is, with time as the wedge will proceed further, it will create some gap which must be covered by the cylinder, else contact will be lost. Do you realize this? If wedge will move forward, the wedge will fall downward in order to maintain the contact. So what kind of velocity relation can achieve this? That's the question. So how the Vx and Vy must have the relation to achieve this? So tell me the component meaning. What is the component of Vx in the direction of common normal? Can you tell me the answer? What is the component of Vx in the common normal? You know component? We take the cos
Vx
of the
sin
angle.
theta.
Vx and theta. Very good. What about the cylinder? What is the component of cylinder? In the same direction?
Vy cos theta.
And if they are not equal, then they will separate, na? Or they will get inside each other. So to maintain contact, to move together, what is the condition? Both must be equal. And that gives a relationship between V1 and Vx, which is called Vy equals to Vx tan theta. We call it constraint relation. Understood?
Yes, sir.
So what you are supposed to do is, in a given question, if you know the velocity of each, draw two arrows at the point of contact, draw a common normal. Second step. Third step is take component by writing the angle, equate it, you're done. That is the whole game of normal constraint. If you want to learn more, I'll share you the link of my previous video lecture. You can watch it in detail. So the normal constraint is discussed in the entire one lecture and so on. So anyway, we are going to learn in laws of motion. As of now, we are doing something more fundamental. All right, guys. Any other doubt you have? Done?
Yes, sir.
You
Thank you.
understood the process, how to think.
Yeah, yes.
There are some finite steps. Like if you think in 3 layer, you can solve any question. Don't deviate from the thinking process. Stick to it. Okay. So, okay, guys. Bye and take care. See you in the next lecture. Be ready for receive some homework for integration, which you all have to practice and submit me again before the next lecture.
Bye, sir. Thank you, sir.
Bye.
Thank you, sir. Bye, sir.